Okay, let's have a look at question 3. Okay, so question 3 deals with graphs in paper 2 as well, but it's not like solving for x and things like that. It's more got to do with your gradients, your tangents, your distance and things like that. So question 3, they've given you the following diagram. They've told you that A is at -2 and 10, B is k and k, and then C is 4, -2. They also tell you that we formed a triangle there for A, B, and C. Line BC is produced to H and cuts the x-axis at E. Okay, and then they've also given you the angle between line BA and the x-axis to be 81.87. Okay, so 3.1 says calculate the gradient of BE. Okay, so looking at BE over there, okay, we don't have the coordinate for B because B is given as k and k, but we do have the coordinate for C, which is 4, -2, okay, and we have the coordinate for E, which is 12 and 0. So because C and E fall on the same line, if we calculate the gradient between those 2 points, it will be the gradient for the entire line. Okay, so therefore if we calculate the gradient, remember it's the change in y over the change in x. Okay, so it's going to be the change in y. I'm taking E as my second point, so 0 minus -2 all over the change in x. Okay, and then that's going to be 12 minus 4, which gives you an answer of 1/4. Okay, note that the answer is positive, which makes sense because that line is increasing from left to right. Okay, now 3.1.2 says calculate the gradient of AB. Okay, so AB, again, we don't have the coordinate of B and we don't have the coordinate of F, but the clue is there. They've given us that angle. Okay, they've told us that that angle is 81.87. okay, which means we need to use something of trig. Now if we look at the formula of gradient, it's the change in y over the change in x. So now if you go and check which one of the following trig functions has the same ratio, okay, and if you go and look, you'll see that tan theta equals to the same ratio. Okay, so we have that tan of theta equals to the change in y over the change in x. Okay, so now in order to solve for theta, we get theta on its own. It's going to be tan -1. Okay, in order to get that on your calculator, you push shift and then tan, change in y over change in x. Okay, which means we're going to have tan -1. The change in y over change in x is the angle produced there, so that's 81.87, and if you plug that into your calculator, you get a gradient of 7. Okay, now 3.2 says determine the equation of BE in the form of y equals mx plus c. Okay, so once again, we don't have the coordinate for B, but if we use C and E, because they lie on the same line, okay, I have B, C, and E, okay, it all works the same as well. So we can use any one of the points, C or E, okay, it's up to you, whichever one you want to use. I am going to use E, simply because the y value is 0. So E is 12 and 0. Okay, so now plugging it into our formula over here, we have y minus 0 equals to our gradient, which was 1/4, okay, times x minus 12. Okay, so therefore y equals to 1/4x, okay, and then 1/4 of 12 is going to give you -3. Okay, now if we look at question 3, it says calculate the following: the coordinate of B if k is less than 0. Okay, if k is less than 0, it means that k needs to be negative. Okay, so therefore k is negative. Alright, so let's see how we're going to do this. Well, up here we've just found the equation of the line that runs through B, C, and E. So now because we have the equation, okay, we can plug in this coordinate over here and solve for k. So we're going to have x equals y, which equals k, so both of them are the same value. Okay, so I'm going to have k for y equals to 1/4k minus 3, x value, y value. Okay, now if you go and sort that out, we're going to take the 1/4 across, so it becomes 1 minus 1/4, which is equivalent to 3/4k equals -3, and if you solve that, you're going to get k equals to -4. Okay, So because k equals -4, don't forget to write the coordinate for b, because that's what they want. So b is then going to be -4 and -4. Okay, so that's the coordinate for b. Okay, now 3.3.2 says the size of the angle at A. Okay, so let's have a look here. We have this angle over here. Okay, so I've redrawn this triangle if you look at the picture there. This is my x-axis over here. Okay, so that's just my x-axis. We have this angle over here. We can determine this angle over here. Why? Because A runs from A through G all the way to point C, and we have the coordinate for C, which is 4, -2. Okay, which means we can calculate the gradient for that. And once we have the gradient, we already saw that the gradient equals to change in y over change in x, which equals to tan theta. Aha, so we can find this angle, okay, in this case not theta, alpha. Okay, so we can find this angle over here, and then we can just use angles of a triangle equal 180 degrees. Okay, so I'm going to do that. I'm going to say that my change in y over my change in x equals to tan of theta, alpha. Okay, and now we just solve. So we plug in for these two coordinates. Okay, note that it's a diagonal line coming down, so therefore I need to get a negative gradient over here. Okay, so if we plug everything in, we're going to have 10 minus -2. Okay, because this is, hold on. Yes, sorry, that's A. Sorry, almost had a heart attack there. So 10 is from A and -2 is from C. Okay, then the next one we're going to have is -2 minus 4. Okay, giving us a negative gradient equals to tan of alpha. Okay, to get alpha alone, we're going to say alpha equals tan -1 and that whole fraction, 10 minus -2 all over -2 minus 4. Okay, and that's going to give you an answer for alpha of 63.43 degrees. Okay, note that this is the angle for alpha, not this outer angle over here. If you wanted that outer angle, you would then have to do angles on a straight line, which means 180 minus 63.43. Okay, so now that we have alpha, we have this 81.87, we can then find beta. Okay, so therefore we know that 180 degrees, okay, must equal to beta plus 81.87 plus then what we've just found, 63.43. Okay, and if you sort out the algebra, you get beta is equal to 34.7 degrees. Okay, and then beta is equal to A, beta equals to A, which equals to 34.7 degrees. Okay, so beta is just the label that I've given it. Alright, now if we look at 3.3.3, it says the coordinate of the point of intersection of the diagonals of the parallelogram ACES, where S is the point in the first quadrant. Okay, so I've redrawn it over here. This is my parallelogram, and now they want the intersection point of these two lines. They're looking for that coordinate over there. What do we know about parallelograms? Okay, the two lines always intercept in the middle of the parallelogram, or they bisect each other. That's the correct word to use. Okay, so for this we're then just going to use the midpoint calculation. So we have A, we have E, we don't know what S is, so it doesn't make sense to try and solve for S first. So use A and E. We know that the midpoint is equal to the following. We're going to have x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. Okay, now if I substitute in those points over there, I'm going to have 12 minus 2, okay, all over 2, and then I'm going to have 10 plus 0 all over 2, so therefore I get a final coordinate for the midpoint as 5 and 5. Okay, so not too difficult over there. Draw the picture if you're not sure, it will help. Okay, now let's have a look at the last question, question 3.4. Okay, so 3.4 says another point T, which is P and P, okay, where p is greater than 0, so p must be positive, is plotted such that the distance of ET, which equals the distance of BE, is 4 and square root 17 units. Okay, then it says calculate the coordinate of t. Aha. So they've told us that this distance equals that distance, which equals to that magnitude. So we're going to use distance formula. So we know that distance formula, okay, is equal to the square root of y1 minus y2 squared plus x1 minus x2. Okay, and that's squared. So we have the distance, it's 4 and root 17. Okay, we're looking for p. So p is going to be one of these values here. So I'm going to use the following coordinate. I'm going to use 12 and 0. It's going to be the easiest. I'm using e. Okay, so therefore we're going to have the square root of 12 minus p squared plus 0 minus p squared. Okay, now it's just some algebra that we need to sort out. So the first thing we're going to do is we're going to square both sides, okay, to get rid of the square root. And if you square this, if you plug it into a calculator, you get 272, which then equals to let's see, 12 minus p squared plus negative p squared. Okay, now if we just sort out the algebra that goes with this, okay, we're going to get the following equation. Okay, I'm sure you guys can all factorize. So we're going to get 272 equals to 144 minus 24p plus p squared plus p squared. We simplify that down, we get to p squared minus 12p minus 64 then equals to 0. Okay, now we have to factorize it. Okay, so 12 and 64, to get to 12 and the factors of 64, we're going to use 16 times 4. Okay, so p minus 16, p plus 4, so therefore p equals to 16 or p equals negative 4. But what was the criteria? P had to be greater than 0, so it can't be this one, so therefore the coordinate for t is 16 and 16. Okay, now moving on to 3.4.2, it says determine the equation of the following. We have a circle with its center at E. Okay, so E is 12 and 0. Then it passes through B and T. Okay, so note what was given here originally. We know that the distance between ET is a radius, and we know the distance from BE is also a radius. Okay, so now we just have to plug everything into our formula. So we have x minus a squared plus y minus b squared equals to r squared. Okay, now a represents the x coordinate of the center of the circle, and b represents the y coordinate of the center of the circle. So we're just going to have x minus 12 squared plus y minus 0 squared equals then to the distance of our radius, which is 4 root 17 squared. Okay, you can leave it like that, or you can then simplify it further if you want to, but it's all you're going to get is then just x minus 12 squared plus y squared equals to 272. Okay, that's the simplest form. Now the last question for this question. Okay, it's been quite a long one. It's 24 marks for this question, so let's get it going. Okay, so 3.4.2, the last question, is for 3 marks. Okay, so it asks you the tangent of the circle at point B, which is k and k. So we found B earlier on, which was negative 4 and negative 4. Now we want the tangent at that point. So if I have my circle over here, there is E, that's T, and this is B. We need a tangent touching the circle. What do we know about tangents? They sit perpendicular to my radii. Okay, so therefore we can use the following formula. Why? Because we already have the equation of the line BE. Okay, so the equation of the line, or sorry, we have the gradient of BE. Okay, so the gradient of BE we saw was equal to 1 over 4. So now we can use this formula to find the gradient of the tangent. So we're going to have m of BE equals, multiplied by m of tangent equals -1. So 1 over 4 multiplied by our tangent's gradient equals -1. So my tangent's gradient equals to -4. Now that I have that, and we have the coordinate of b, we can find the equation of the line using y minus y1 equals mx minus x1. Okay, so y minus 4 equals to -4 x minus -4. Okay, so lots of -4s here. And if you sort that out, you're going to get an equation of y equals to -4x minus 20. Okay, it makes sense. Why? Because this needs to move downwards since this one's moving upwards. So this one has a positive gradient, this one must have a negative gradient. Okay, and that's how we go about doing this question. Okay, this maths video was a bit of a long video today, but if you guys are enjoying it and if you found the video helpful, please leave a thumbs up on the video. It does help me out a lot. If you are enjoying the content and you're not subscribed, then please click the subscription button down below and put the bell on so that you guys are notified every time I upload new videos. If you have any comments regarding the following math section, then please leave them in the comment section down below. I'll get back to them as soon as I can. And remember, it's never too late to have an OIC moment.